In section 1A, we're going to be talking more about absolute value. Specifically, equations and inequalities. Now remember the definition of absolute value. The definition was absolute value just means the distance from 0 on a number line. So let's figure this out. First, we'll start off with solving equations. And you've seen some easy ones like this before. So if I asked you to solve the absolute value of 5 minus 3x is equal to 12, well, that means that what's inside, the absolute value of what number is 12? It could either be 12 or negative 12, right? The absolute value of both of those would give us 12. So generally, the way we get rid of absolute value is we break it up. We say 5 minus 3x would equal 12. And what if 5 minus 3x was equal to negative 12? Well, we could bring the 5 over, divide by negative 3, and then we could do the same thing here, bring the 5 over, divide by negative 3, and that would be our answer. So these are pretty straightforward, and I'm sure you've been seeing these for a while now. The second problem is a little bit more interesting. What if we had the absolute value of 4x minus 3 is equal to the absolute value of x plus 6? Now here's the tricky part. If I take the absolute value of 3, that's technically equal to the absolute value of negative 3, right? So one could be 3, one could be negative 3, or maybe both are negative 3. So we're going to have to account for that. So either both are positive or negative, or maybe either they are opposites, meaning like one's positive and one's negative. So let's see if we could figure this out. If they're equal, that means that 4x minus 3 is equal to x plus 6. That's if they're both the same. Now if they're opposites, that means that 4x minus 3 would equal the opposite of x plus 6. Now you could have even put that negative over here. It doesn't matter where it goes. Bottom line is you're taking the opposite of one of those sides. All right, so let's see what we get here. We bring the x over, we get 3x is equal to 9. X would be 3. And same thing here, we get 4x minus 3 is equal to negative x minus 6. So 5x is equal to negative 3. X would be negative 3/5. That's how we solve some absolute value equations. Let's just do one more. What about if we had something like this? And if we had the absolute value of 5x plus 15 is equal to 0. Generally, I'm a big proponent of follow the same steps, so we don't have to learn something different here. So I'm going to write 5x plus 15 is 0. We always keep one side the same, and we always take the opposite of the other side. Well, technically, the opposite of 0, of course, is still 0, so of course we'll get the same answer. We have 5x is negative 15, so x is negative 3. Bring the 15 over, and we get x is negative 3. All right, so that's what that would look like. You could always check your answer, plug in negative 3, you get negative 15 plus 15, of course, is 0. So now let's move on to inequalities. So when we have inequalities, this is like a little bit trickier, but I'm sure you can handle this. So remember, the absolute value of x just means the distance from 0 on a number line. If I said this was equal to 4, what that would look like, just based on the definition, means any number that's 4 units away from 0 on a number line. Just based on the definition, that's what it means. What if I said absolute value of x is less than 4? That means the distance from 0 on a number line, any number that's less than 4 units away. Well, all of these numbers are less than 4 units away. All of these numbers are less than 4 units away. So you can see that this is actually an AND graph. What if I did the opposite? What if I said greater than or equal to 4? Well, that means on a number line, all the numbers that are greater than 4 units away from 0. Okay, well, like 5 is, right? All of these numbers are, and all of these numbers are. So this is what an OR problem looks like. Now, it's a little bit corny, but let me explain how I remember this. If you read this sign is a less than sign. So you'll remember to put AND when we're writing the solution. And remember, sometimes with AND, we could write them as a compound inequality. If it's an OR, well, what does this sign say? This is a greater than sign, right? That's generally how I remember them. When we have an AND problem, the answers have to satisfy both, meaning x has to be less than or equal to 4, and x has to be greater than or equal to -4. If it's an OR problem, we just have to satisfy at least one. So, I mean, you could just say x is less than or equal to -4, or x is greater than or equal to 4. So like 5 would work. It would work here, it wouldn't work in the other one, but we only have to satisfy one. Okay, so let's actually do some now. What if we had a problem like this? The absolute value of 2 minus 5x is greater than or equal to -4. Now right away, I'm looking at this. The absolute value is by itself. That's how you always want to get started. That's a greater than sign. I'm going to start off by saying or here. We're going to have 2 minus 5x. It's greater or equal to -4. One side's always staying the same. And on the right side, what we're going to do is say 2 minus 5x is less than or equal to -4. So we're still taking the opposite of the right side, but remember with inequalities, when you do that, that means you also have to switch the sign. We talked about this in the last section. If you multiply a whole side by a negative, like look, that's what I should have done over here. -4 times -1, right? We said you have to switch the sign, and that's what I did. Instead of being a greater than, I made it a less than. So let's go ahead and solve this. We get 2. Let's see. If we subtract 2, we get -5x is less than or equal to 2. And x would be greater than or equal to -2/5. And let's do that here. -5x is greater than or equal to -6. So x would be less than or equal to 6/5. Just take a look at the graph real quick. 6/5, -2/5. So we're looking to see, okay, all these numbers are less than 6/5. All of these numbers are greater than -2/5. So what would actually the answer be? Well, we're looking to satisfy both of them, or one of them, right? So what about 0? Like if I let 0, that would be less than 6/5, right? But it also works here. So what about, let's say, 10? 10 is greater than -2/5, or less than 6/5. Well, it's not or that one, but it definitely satisfies this one. So 10 works. What about -10? -10 is less than 6/5. Doesn't work over here. So it looks like, according to this, the whole number line would be shaded. So we say that the answer would be all real numbers. Why is that? Whenever you take the absolute value of a number, you're either going to get 0 or a positive number, right? So the absolute value of what number is greater than -4? Well, any number. And you could see that play out in the graph. So I would recommend graphing just to double check your answers, but once in a while you'll wind up with a weird answer like this. But if you graph it, you could see that, yeah, the whole number line is shaded. All numbers are either less than 6/5 or greater than -2/3 or -2/5. What about a problem like this? The absolute value of 4x minus 7 is less than -3. Well, absolute value can't be less than -3, so right away I'm seeing like a red flag here. Let's break this up and say 4x minus 7 is less than -3. We'll keep everything exactly the same. And here we'll take the opposite of the right side, and then we'll switch the sign. So this would be 4x is greater than 10, x would be greater than 5/2, and here we have 4x is less than 4, x would be less than 1. This sign right here is an and sign, right? Less than. So let's draw a graph and just see what the answer is. Here's 5/2 is like 2.5. Here's 1. So give me numbers that are less than 1 and, meaning both, greater than 2/5. Well, you could see with ands, remember we're looking for the intersection. There is no intersection here. The answer would be no solution. It's no solution because absolute value will never give you a number that's less than -3. Okay, we'll do one more. What if we said 2 times the absolute value of x plus 1 minus 3 is greater than 5? Let's actually even maybe put a negative in front. So -2 times the absolute value of x plus 1 minus 3 is greater than 5. Well, we can't say it's an or right away. We always have to isolate the absolute value first. Okay, so that means adding 3, just like if we were going to solve a regular equation. Divide by -2. I'll get the absolute value of x plus 1 is less than -4. So you could actually see, if you jump the gun, it looks like an or, but when you isolate the absolute value, it actually turns into an and problem. We'd get x plus 1 is less than -4, and x plus 1, switch the sign, take the opposite. We get x is less than -5 and x is greater than 3. Well, would that ever work? Here's -5. Yeah, no, that would never work. And here's 3. There's no overlap, so for this one there's also no solution.